Well, hello everybody. Hey, it's been a little while since I posted this. I actually thought I had this video done already, and I was just getting ready to leave. And I looked back and I realized that in my head I had done this one, but not in my computer, evidently. So we're going to give another look at a nice free response question centering around the idea of particle motion. I don't think this one looks too bad to me. So let's see how we do here. So what we've got is two particles, two separate particles that are moving along the x-axis from 0 to 8 seconds, from time is 0 to time equals 8. And the position of the particle P is, oh no, it's a natural log. We don't necessarily always like those so much. While the velocity of the other one is given by, now notice this is a velocity, that's not a position function, that's a velocity function given by this one. Sorry, my printer is not very good, so some of these are a little bit fuzzy looking. So hopefully this is legible, but I'm going to put a copy of that up for you that you can actually look at that's really nice and clear. Anyway, so it's asking when specifically this first particle P is moving to the left, and this was a position function particle. So in order for me to know the velocity function when it's moving left, I want to know when the velocity is negative. So v sub P of t. Now we want to remember that is actually x prime of P of t. And so remember, when you take the derivative of a natural log, chain rule says it's 1 over what's inside times the derivative of what's inside. And the derivative of this thing inside is 2t minus 2. Turns out the numerator factors real nice, but the denominator doesn't. And this is one of those questions that I thought was a little bit tricky. You know, when you look at it, I don't know that everybody would think about that, but one of the things that I personally did, because I thought, well, that's kind of weird, I wasn't certain when this thing, because it wasn't factorable. So, you know, honestly, you know that it's opening up. I did the quadratic formula on it, and I found out that the answers were imaginary, meaning this thing never crosses the x-axis. So I have an upward sloping parabola. I didn't show that work here, but this is an upward sloping parabola that never crosses the x-axis, which means this denominator here is always positive. So effectively, if I make a little graphic organizer, I know that this velocity hits 0 at the number 1, and any value above 1, it became positive, and any value below 1, even all the way to infinity, was negative. But this graph only is valid from 0 to 8 seconds. So it appears that P is moving left in the region of t that starts at 0, because at 0, even though 0, it's kind of strange to say something is moving to the left at 0, but effectively when we opened our eyes and looked at this thing at time 0, it was moving to the left until 1, but at 1 it is no longer moving to the left. It is actually stopped because its velocity would be 0. Now moving a little bit further down, it's asking when both of the functions are moving in the same direction. Well, we know a little bit about P, so let's put P of t right here. Let's see, P of t looked like it was this way, and it was moving this way and this way. So let's figure out what is happening about Q. Now, Q of t, v sub Q of t, is a simple little function like this. And as it turns out, that one was just hung out there for us, just like a nice soft pitch. It factors beautifully to t minus 3 and t minus 5, meaning at 3 and at 5, the velocity of this particular function would be 0. Again, this is an upward sloping parabola, so without doing any real math, I should know that the graph should be up on the left and right and down in the middle. And that leads me to a simple little thing to say, when are they going the same direction? And I hope you can kind of see that right in here, everything. So now keep in mind, the reality only begins at 0. So we don't really know much beyond 0. But what I see is this one is going to the left, this guy is going to the right, but in this little region right in here in between 1 and 3, they're going both to the right, then P is going to the right while Q is going to the left, and then out here it's going the same direction. But again, the problem is only defined from 0 to 8, so that's the only region I need to talk about. So I'm just going to simply say that both particles are moving left for values of t specifically that are between 1 and 3. And then in the same way, I could say both particles are moving right in that other region up here that starts at 5 and moves till 8. But what's a little bit interesting about that is that at 8, it's not 0. It is actually still moving positive on both of these pieces of data. Okay, so that wasn't too bad. Now, when we move on to C, it says find the acceleration of particle Q. So specifically, the acceleration of particle Q. So what I need to look at is, first off, v sub q of t was given to be t squared minus 8t plus 15. And I know that v prime of q of t would be a of q of t. I really don't like the notation of this problem. These should be subscripts, but I just am not writing them particularly well. And that would give me 2t minus 8. So a sub q of t that's just a little better stated, would be here. So a sub q of 2 would be 2 times 2 minus 8, which would be negative 4. And it says to find this, and it says, is the speed of the particle increasing or decreasing? Well, again, I know that it's decelerating, but then the other question becomes then, what was v sub q of 2? And v sub q of 2 would be, of course, 2 squared minus 8 times 2 plus 15. So that'd be 4 minus 16 plus 5, which is negative 7. Now, the specific value that we have, oh, that was supposed to be plus 15, wasn't it? So that would be, let's see, 4 minus 16 is negative 12, and negative 12 plus 15 is actually a positive 3. At least I caught that before I kept going. So it appears to me that it has a negative velocity, negative acceleration, and a positive acceleration. And so I'm simply down here going to say, since the velocity and acceleration have opposite signs, S-I-G-N-S this time, since they have opposite signs, the particle is slowing down at t equals 2. Now, a common error that people make in calculus classes and on AP tests is they will just say that it's slowing down, period. But just like in an English class, you want to restate that you validate what you are actually trying to find. Now, the last little question that they have here is find the position of the particle the first time that it changes directions. Okay, so what we want to know is, we're looking at q. So again, keep in mind v sub q of t, which is t squared minus 8t plus 15. If I want to find the position function, I need to integrate this. So s sub q of t would be the integral of v sub q of t, which would be 1/3 t cubed minus 4t squared plus 15t plus c. And right away, we're like, oh no, I don't know what to do in this particular problem. But if you go back, there was something that I did not mention early as I read this, but it says particle Q is a position 5 at time 0. They just threw that one in. I didn't need that for a long, long time. But they're telling me that S sub Q of 0 is 5, which would lead me to say that if I plugged in 0 for t right here, then C has to be 5. So specifically, I know that S sub q of t would be 1/3 t cubed minus 4t squared plus 15t plus, in fact, 5. Now, we learned earlier that the first time that this particular particle changed directions, going right back to here, notice we knew that it was going forward, then it went backwards, and then forward. So this is the first time that it changed directions, was at 3. So they're asking me now to find out where that particle is at that moment. So in other words, what is the position at time 3? So we're just going to go ahead and pop all that information in. This is a little bit irritating that we have to do all this arithmetic, but they did make pretty nice numbers to play with here. And it turns out you do a little bit of arithmetic, and that comes out that this position is at 23 at that moment. So one of the tricky parts of this particular question is you feel like you're done with that idea, and then all of a sudden they're going to bring that idea back later on in the question, and they tend to give you that initial condition value up in that given information. And so by the time you're at the end of the question, you're not seeing that initial layout, and you don't realize that they actually gave you something that you needed really, really early on. So it's important in AP tests as well as college classes that as you're going through those A, B, C, D, E problems, that you go back and you relook at that initial given information and make sure that there wasn't something in that snuck in that was actually important and that you maybe just didn't even realize you needed at the time, but you will need later. They very rarely give you information that is irrelevant. So anyway, I hope that worked great, and I would love to see you work on the next problem on your own, and you'll see some more information about that when you look online. Have a great day.